Hi, my name is Bahadur Ahmedov. Welcome to the course of Probability and Statistics. In this video, we are going to discuss a little bit about the multiplication rule, and we're interested to evaluate the probability of the A and B. It appears it has the two different meanings. One meaning is A and B happen at the same time in a single trial. A and B in the single trial. And at the same time, probability of the A and B might mean that A happens, then B happens. So depending on what we need to find, the first case or the second case, we need to use the two different formulas to evaluate this probability. So for the first case, when we would like to evaluate the probability of the A and B, we just need to find the the intersection of the two sets, A and B. And we are interested to know whether these two events are mutually exclusive or not. So if you remember, so the mutually exclusive mean that the two events are called mutually exclusive if they cannot intersect, so they don't have the intersection points. So in this case, so let's say you roll a die, and let's say A is going to be the outputs 1, 2, 3, and the B is going to be the outputs, for example, 4 and 5. So if I would like to find what's the probability of the A and B, it depends whether they have the intersection points or not. So if they don't have the intersection points, if they don't so these two events cannot happen at the same time together in one trial. And one trial means just rolling a die once. So this is simply going to be equal to the 0. If we change this a little bit, for example, let's say I've got another set C, which is going to be 1, 3, and 5. And if I would like to find, for example, probability of the A and C, in this case I need to find the elements from the A and C which are participating in both of the entries at the same time. So for example, 1 and 3 are included in both of the sets, and the probability of the A and C in this case is going to be 2 over 6, right? Because there are in the sample space the 6 numbers from 1 to the 6, because the die has the 6 sides, and the sample space in this case is going to be the numbers from 1 to the 6, and the two of them are participating in both of these events, so they are in the intersection point. So that is why probability of the A and C is going to be 2 over 6. So this is the first case when we mean that the A and B happen in a single trial. But there is another case when we are looking to this probability of the A and B from the different perspective, when you do multiple trials of your experiment. So the same example, so let's say you roll a die. The sample space is going to be 1, 2, 3, 4, 5, and 6. So let's say A is going to be equal to the 1, 2, and 3. B is going to be equal to the 4 and 5. So what I want is I would like to find the probability of A happens in the first trial and B happens in the second trial. So basically you roll now the die twice, one time and the second time. So probability of the A happens in the first trial is going to be equal to 3 over 6, right? Because there are 3 items in the A. And we have to find the probability of the B, so which is going to be equal to the 2 over 6, because there are 2 items in the B. And it appears we have to multiply them. So if we want that A happens first, then B happens in the second trial, we just need to multiply them. The multiplication is going to be equal to the 6 over 36, or 1 over 6. So we basically need to know what we mean by the probability of the A and B. So if it means happening both of the events in a single trials at the same time, then we need to find the intersection of these two sets. And in this case, it is important for us to know whether the two events are mutually exclusive or not. If they are mutually exclusive, then the probability of the A and B is equal to 0 because they cannot happen at the same time. And the second meaning is that probability of the A and B means that A happens in the first trial and B happens in the second trial. So in this case, we just need to multiply them. In this case, we're going to talk about so-called dependent or independent events. And we are going to talk about the independency of the two events in our next videos. So in this video, I would like to finish with a small example of the multiplication rule of the second type. Example. So let's say we are going to do an experiment. So we need to roll a die, and at the same time we need to toss a coin. So what I want is, so let's say A is going to be event when we get 3 or 4 when we roll a die. And the B is going to be event when we get the tails when we toss a coin. So what I want is, I would like to find the probability of the A and B. So obviously it is going to be the second case, right? So what I want is, so when I roll the die, I need to get either 2 and 4. And at the same time, I have to get the tails when I toss the coin. So in order to do this, I need to find the probability of the A first, then multiply this to the probability of the B. So in this case, probability of the A, what's the probability of rolling a die and getting result either 2 and 4? It's going to be 2 over 6, because there are 2 items in it, A, and 6 items in the sample space. And we have to multiply this to the probability of the B, which is getting a tail when you toss a coin. It's going to be 1 over 2. So the answer is going to be 1 over 6. So this is simply the multiplication rule when these 2 events are independent. What happens if they are dependent, and what does it mean? We are going to discuss in our next videos.